Hello everyone, welcome back to another endless numerical fun video. Today we'll be solving ODEs through the method of separation of variables. But first of all, what even is an ODE? Well, I can raise a few examples. dy by dx equals 6x, or maybe y prime plus 3y equals x. These are all differential equations because they have this differential operator, dy by dx, which simply means the rate of change of something, so how fast y changes in proportion to x. And when we solve differential equations, we're not solving for a value like y equals 7, we are solving for y of x, which is a function, or more specifically, a family of functions, because they all have the derivative at that point, and I'll show you why later. These differential equations are very useful in modeling evolution, so that you can see them in engineering, in mathematics, in physics, etc., etc. They're almost seen everywhere. So it's very important to know how to solve these differential equations. And today we're going to solve some of the most simplest forms of differential equations, dy by dx, or I can write it y prime, equals f of x. So what this means is, with a small change in x, there is a change in y that is proportional only to x. So the size, the magnitude of the change in y only depends on x itself. And how we solve this basically extends from the limit definition of the derivative, which is delta y by delta x, and this is basically a fraction. So what we can do is times dx to the other side to get f of x dx equals dy. To get rid of the dx's and the dy's, we can integrate. And I want to say on the left hand side, when we integrate dy, this is basically like integrating the constant 1 times dy. Now to get the general solution is very simple from here. Integration of 1 with respect to y is y, and this is going to be equal to f of x plus c. Now, why do you think we have the plus c? Well, maybe in your Calc 1 class you said, oh, we just have to add it on, and your teacher would get mad at you if you've forgotten. But I want to show you here why it's so important. If we get, say, y of x, the function that we get from the differential equation is perhaps x squared, something that looks like this. Well, another function that has the exact same derivative at that point would be this function. See, they have 0 at 0, a slope of 0 at 0, and another one would be this one. So these are all downwards or upward shifts, and this is where the plus c comes in, which is basically just a shifting transformation along the y-axis. So we can try using this method to solve some basic differential equations now, which is we times dx on the other side and we can integrate. So I've got a few practice problems for us to try, and they all have different challenges for you to try. So the first one is dy by dx equals x minus 2 squared. And some of these might seem easy to you, but I just really want to practice and practice, because that's how we can get perfect at stuff. So if we multiply by dx on the other side, we get x minus 2 squared dx equals dy. Integrating both sides so that we can get rid of the dx's, because this is what we learned with integration, we get y of x, so this is the 1 times dy on the left hand side, equals this integral. Now what I can do to solve this integral is I can let u, and this is a classic use of, let u equals x minus 2. To most of you, you might know the steps already. The use of basically means nothing, but I just want to show you why the whole steps, and some of you may even expand it, so that's another method. As long as you get the answer, I suppose it's fine, as long as the working is correct. So now we can differentiate du by dx equals 1, because it's only x to the 1. Now we can times dx on the other side, so we get du equals dx. So now let's sub this back to our equation. So remember, x minus 2 is u, so this will be u squared, and dx equals du. Now using the power law, I think that's what it's called, is u cubed over 3 plus c. Now if we sub back in our u to the x term, y equals x minus 2 cubed over 3 plus c. If you want to know how we find this plus c, you really have to do an initial value problem equation where we basically sub it in. But perhaps that's for another video. But essentially, we've now solved the differential equation. This is basically the answer to this. And it says that the function y that always has a derivative of x minus 2 squared is this function. And this is basically a family of functions because of the plus c term. So this is actually quite simple. If you feel like you've got the hang of it, I suggest you can pause the video, practice some of the problems, or even just finish watching the video, or watch it in 6 or 2x speed. So the second equation is going to be dy, oops, I have it in red pen, I should have it in white, dy by dx equals x times the square root of x squared plus 9. And this equation seems like another u sub from the get-go. So I can do the basic steps, x times x squared plus 9 dx equals dy. Integrating both sides, we get y of x equals. And here, I think normally you u sub the one that's in the parentheses or in the indices. So this is basically x squared plus 9 to the power of 1/2. So I'm going to put x squared plus 9 as my u sub. So let u equals x squared plus 9. Du by dx equals 2x. So du over 2x equals dx. Okay, so I'm going to sub this back into our equation. So x is left alone. Now it's the square root of u and du over 2x. So now notice how the x's cancel out. So now we are left with the root u du and times by 1 over 2. And notice how I can take this constant out because it's basically just a constant. So root u is equal to u to the 1/2, and we can use the power law again. So this can be 1/2 times u 3 over 2 over 3 over 2. So we can times the 2 on the top later, and then we can plus c. Okay, so this 2 and this 2 cancel out, so we get u 3 over 2 over 3 plus c. And if we substitute our u back, we get that y of x, oopsies, y of x equals x squared plus 9 to the power of 3 over 2 over 3 plus c. And this is our solution to the differential equation dy by dx equals x times square root of x squared plus 9. Now let's try a few more. This is really basic integration, but as long as you get the hang of it, I think I've accomplished my mission in showing you. So of course all of these videos, they're going to include lots and lots of practice questions. So the next equation is going to be dy by dx equals 10 over x squared plus 1. Now if we apply the same steps, dx equals dy equals 10 over x squared plus 1 times dx. Integrating, we get y equals, and then we can take this 10 out because it's a constant, so it will be 10 times 1 over x squared plus 1. And this one, dx. And notice this one is basically just the trig sub of arc tangent of x. So of course you really have to memorize these ones, I think, because these ones are quite hard to get yourselves, but you only have to remember 3, the arctangent one, the sine one, etc. But oops, I haven't finished it yet. Arctangent of x. So this would then be equal to 10 times the arctangent of x plus c. And really I should have written 10 times arctan of x plus c, but 10 times c is also constant, so I can basically write it how I've written it. And that's just a little trick for you. That's how some mathematicians get you. But this is also going to be our solution to the differential equation dy by dx equals 10 over x squared plus 1. Now on to our final one. So we've had trig sub, we've had u sub. So of course I think you can predict we're going to have one final one, which is going to be an integration by parts. And I don't do my integration by parts the normal way or the ordinary way. I think I do it through the di method. So let me write the equation first. Dy by dx equals x times e to negative x. Of course you can tell it's already the product x times e to negative x. But of course by formality we have to write it out all again. X times e to negative x dy integrate, and this is y equals, and then this. So of course I'm going to write my di here. If you have other methods of solving integration by parts, perfect, you can do that. You should do that actually. But for me, I'm going to put x as the one that I'm going to differentiate, because x can always go to 1 and then 0, and then e to negative x is the thing I'm going to integrate. So if I integrate it once, it's going to be negative e to negative x by the chain rule, I believe, and then e to negative x. write my negative plus signs, and I times these two because this one can't times into anything. So the solution to my integration operator is going to be x times negative e to negative x minus e to negative x plus c, which is going to be negative x e to negative x minus e to negative x plus c. Of course, you can factor out the negative e to negative x, but this is yet another solution to our dy by dx, which is the differential equation. Now, this is supposed to be the end of the video, but I want to do a little bit of bonus with perhaps this equation. Oops, I erased it. How clumsy of me. Plus c. And I'm going to show you what the initial value problem is. So I'm going to erase all of this first. So remember when I said that we had to find this plus c term? This plus c term, because it's basically a family of functions. Remember, it's the upward or downward shift. So let's say that our function y of 0 crosses 0. So it crosses the origin. So basically what we do, we have that y of x is this equation. So we just basically sub in 0 for x, and then we can equate it to get c. So if I were to do it quickly, y of 0 equals negative 0 times e to the negative 0 minus e to the negative 0 plus c, and then this equals this 0, so equals 0. The zeros might get confusing because I have 0 twice, but this 0 essentially equates to this 0, and this 0 equates to that 0. So what we get is that 0 times that is basically 0. This term goes to 0 minus, and then e to 0 is 1 plus c equals 0. So that means that c must equal 1. So thus, to solve our differential equation with the initial value, we get that c equals 1, meaning that it crosses, c has to cross 1 for this family of functions. So if we write out the full equation, so if I write it out fully, so the y of x that follows dy by dx equals x e to negative x that crosses the origin is, and this will be y of x equals negative x times e to negative x minus e to negative x plus 1. And that was just basically a little bonus for our video. And if you want, we're probably going to make a video on initial value problem, but this is going to be our solution to this equation. Now, I really hoped you enjoyed this differential equation video. I hope that there's going to be more to come if you guys enjoy it, of course, and hopefully I get to teach you more. So thank you all for listening, and I've hoped you've learnt a lot today.